All right. Let's see. Oh. All right. So before I start talking about the exam or the project, are there any questions for me? Does anyone on the call have any questions at all about basically it could be chapters 4, 5, or 6. You have an exam coming up in a couple of days.
I wanted to just kind of ask about how I know that usually we calculate the results in Z-score when we have like the mean 0 and the standard deviation 1, but sometimes we're given an X value and we can convert to Z-scores. So how would I know when I need to convert and enter the results in Z-scores or like the X values results? Like I had that and like one problem, so I wasn't sure. So I would try one thing and the other, but like how would I know in the exam?
All right, so I want to be very clear about something. When you look at the help me solve this option on MyMathLab, and this goes for everyone, that is not the way that you have to do a problem. That is one solution. And on MyMathLab, when you look at the help me solve this, they are not using Excel. So in this class, under my instruction, and in every single one of my videos, I use Excel. So my solution is not the same as the solution that you're shown on MyMathLab. The answers are the same, but the way we get to those answers are different. Also, in my lecture video last week, in 6.1, 6.2, and in any of my other, and in all of my Excel videos, I've really emphasized that there is no way that you have to do these problems. So there is not a situation where you have to use X values or that you have to use Z scores. In fact, in one of my videos, I solved the problem both ways to show you that you can use either X values or Z scores, and you will always get the same answer. So that's the first important point. There is not a situation where you have to use Z-scores or you have to use X values. Please don't think that when you click on help me solve this and it uses Z-scores that you have to use Z-scores, because you're not using that table of values that's in the textbook and that table of values they use in the solutions. You're using Excel. So if the original problem gives you X values, so I don't want to think about in terms of what you have to do. Let's think about what's easiest. I think that's most important. What's most efficient and easiest for you? If the original problem gives you X values, I would say just stick with X values because there's an Excel function for that.
Mm-hmm.
If the original problem gives you Z scores, stick with Z scores. So you have those two Excel functions. Let me
Yeah, because I definitely understand like the Excel functions, like the standard deviation one and the other one without the S. But
yeah.
yeah, I think that makes sense. I was just because I have used also the help me solve the
Mhm.
like the feature on MyMathLab. So I guess that got me a little bit confused. So that's why I just wanted to make sure so that on the exam I don't have that doubt about like how should I address this problem or like,
Yeah,
but
and
that
I'm
makes
glad
sense.
you asked this question. It's a great question. Because yeah, anytime you see like a difference or a discrepancy in a written solution you see online versus my solution, it's important to offer the clarification. But I do want to say I'm talking only about section 6.1 and 6.2. So back in week 10, when we first introduced those normal distribution functions on Excel and the area and the normal distribution graph, all of that. When I say you could use whichever method you want, X values or Z scores, I'm only talking about 6.1 and 6.2. Keep in mind, this current week with the central limit theorem problems, and I also mentioned this in my video, you have to use Z scores in 6.4 because you're not given X values.
Okay.
Right? You're given the value of X bar. You're given the sample mean. So since with the central limit theorem problem, since you're not given one specific X value, then you have to, for every central limit problem, you have to convert to Z scores. And that was that, let me pull up my whiteboard. Oh, I have some stuff here. So in section 6.4 with the central limit theorem, that was that Z equals X bar minus the mean divided by the standard deviation over the square root of n. So for these problems where you're given X bar for a sample, like well, when you're given a sample mean, you have to use Z scores because you have no X values. So let me actually pull up a couple of problems. So let me first go to 6.2. Or actually, let me go to the chapter 6 practice test. Hopefully I could just pick one at random. Okay, so here's a problem from section 6.2. So you're given that women's heights are normally distributed with a mean, the standard deviation, also the men, mean and standard deviation. Consider an executive jet that seats 6 with a doorway height of 55.8. So you're given one specific value. Excuse me. So in this problem, you could plug these given numbers directly into Excel, stick with X values, or you could convert them to Z scores and do it that way. Personally, I would say stick with X values because that's what's given. All right, so this is the problem 16 on the practice test. All right, so suppose an airline uses a seat width of 16.4 inches. Okay, assume that men have hip breadths that are normally distributed with a mean of 14.2, a standard deviation of 1. Okay, so we're given mean and standard deviation. So part A says find the probability that if an individual man is randomly selected, his hip breadth will be greater than 16.4. Okay. So we have the normal distribution. We're given that men have hip breadths with a mean of 14.2. And you could only fit in the seat if your hip breadth is, or your breadth means width, the width of your hips is less than 16.4. So the question is, find the probability that an individual man randomly selected, the hip breadth will be greater than 16.4. So 16.4, maybe over here somewhere. And the probability that one randomly selected person has hips wider than that, so greater than 16.4, we need to find that area. And we're also given in the problem, the standard deviation is 1. So we're given the mean, the standard deviation, and the x value of 16.4. So we would say equal norm dot dist. The x value is 16.4. The mean is 14.2. The standard deviation is 1. And for cumulative, we always use true, or you could type the number 1. So what I just typed, that's not going to work because that only gives us area to the left, right? This problem is saying greater than. That's keyword, the keyword greater than. Greater than means above or to the right. So to find that red area, we need to find the complement. So we need to do 1 minus the area to the left. So I need to put in a 1 minus into that formula. All right, so we're sticking with x values because we're given x values. And yeah, looks like we're good. 0.0139. Okay. That was, even though this is a 6.4 problem, part A was like a problem from 6.2. But keep in mind, this is talking about the probability of one individual person. Part B, now this is a 6.4 problem. This is not talking about one single person. This is saying with 122 randomly selected men. All right, so we have a sample of 122. Find the probability that these men have a mean hip breadth greater than 16.4. So we're talking about the average of a group. When it's an average of a group, now we're talking about the central limit theorem. So when you're taking the exam, that is how you determine what approach to take. When it's one individual object or person, it's a regular normal distribution problem. When it's talking about the average of a group, that is the central limit theorem. Okay, so for part B, let's say for part B, we're given n is equal to 122. Okay, so for part B, it's saying find the probability that the average of that group of 122, find that probably the average is above 16.4. So it's the same graph. It's the same normal distribution shape, except we have to use z-scores. These are x values, those are z-scores. So we have to use z-scores, and we have to use z equals x bar minus the mean divided by the standard deviation over the square root of n. And so we're given all four of these numbers in the problem. The mean is the 16.4, or sorry, the sample mean is 16.4. The population mean is 14.2. The standard deviation is 1. And n is the sample size, 122. So we're still looking for area to the right of some number, but in this case, we have to convert that 16.4, that sample mean, we have to convert that to a z-score. So equal, so what I like to do in Excel, just to make sure there's no mistakes with order of operations, I always put parentheses around the numerator and parentheses around the denominator. So when I'm typing it into Excel, it's like equal parenthesis top divided by bottom. Okay, so equal 16.4 minus 14.2. And I'm typing the numbers in manually, but on our Zoom call earlier this week, this is where I showed you how to make a template for this. So you could just plug these numbers in. But for right now, I'm just going to do it manually. Okay, so 16.4 minus 14.2. Okay, that's the numerator. Divide that by, in parentheses, 1 over SQRT for square root, 1 over the square root of 122. So that gives us the z-score of about 24.3. That's a very, very, very large z-score. So now to find the probability, now we have to go to, I'll do 1 minus because we've already talked about that, 1 minus. Now we have to go to the norm.s dot distribution because we switched to z-scores. So we have to use the dot s. And our z-score is 24.3. And always comma 1. And the answer is 0. It might not be exactly 0. Somewhere. Oh. Yeah, somewhere down the line, if I use enough decimal places, I'm thinking I should maybe get a decimal place. But all right, that doesn't really matter. Because in the problem, we're only rounding, I think, to 3 decimal places. Let me do that one more time. Equal norm dot s dot dast minus. Okay. Well, screwing it all up here. Yeah. And we're rounding to, I think, there we go, 3 decimal places. So keep in mind, for the regular normal distribution problems, when we're talking about one individual object or person, you have the option to use either one. As soon as you see the word, find the probability of, a mean, like here in part B, if the plane is filled with 122 randomly selected men, find the probability. So if you see the word probability and mean in the same statement, that's telling you it is a central limit theorem problem. Okay. So is that clear? Does anyone have any questions about that explanation?
Yeah, it helped me. So yeah, I feel better now. Thank you.
You're welcome. Yeah, I mean, this is a common mistake that I've seen, because I've been teaching statistics for so long, especially like with this second exam, knowing when to use normal versus normal standard, right? When to use the normal distribution versus the central limit theorem. It's important to be really clear on when to use what method. Okay. Any other questions?
Professor,
Yes.
can you go over like the question on the practice exam on chapter 6, number 12? It's like the introduction for that for 6.1, but I watched the video too, but I still have like doubts how to approach it.
Is that this problem?
Yes, please.
So 3 randomly selected households are surveyed. The number of people in the households are 2, 4, and 9. Assume that samples of size 2 are randomly selected with replacement. Listed below are the 9 different samples. Okay, so first thing I'm going to do is copy this over to Excel. Hang on, for some reason my mouse is not working. Let me try that again. Okay. Okay, find the variance of each of the 9 samples. Then summarize the sampling distribution of the variances in the form of a table. Okay, so we have to calculate 9 sample variances. So this is like, that's sample number 1, 2, 2. And that's sample number 2, 2, 4. So we have each pair of numbers as a sample. Okay. Okay, so we want the variance of the 2 numbers to the left. That should be easy enough. We have a function for that, for variance, var.s. That's our function for sample variance, and we want the variance of these 2 numbers, b2, c2. All right, so that will give us the variance of the first sample, and then we could just copy or drag that down to get the next 8. So we do it once, Excel will do the next 8 for us. Okay, so in blue, these are the 9 sample variances. All right, so we have this list of numbers, and so the number 0 appears 3 times. Looks like the number 2 appears twice. The number 12.5 appears twice. And the number 24.5 appears twice. So we have 9 numbers here. Now, if I were to say, here's 9 numbers, pick one at random. Or like, let's say there's a 9 slips of paper with these 9 numbers written on them, and you reach into a bag and you pick one at random. Well, what's the probability of selecting the number 0? Well, there's 3 zeros in there out of 9 numbers. So when we go back over here to the problem, the probability for the number, the probability of a sample having a variance of 0 should be 3 out of 9, because out of the 9 samples, 3 of them, so I'm looking over here, out of the 9 samples, 3 of them have a variance of 0. Or if I said, what's the probability of picking the number 2? Well, there's 2 of them, there's 2 2s out of 9 samples, so the probability would be 2 over 9. And so on. So that's where these probability numbers come from.
Thank you.
Oh, you're welcome. And then part B and C, compare the population variance to the mean of the sample variances. Two, 4, 9. Okay, so the population is 249. So we can find the population variance. That's VAR dot P for population. So there's our population variance. And then we could go over here and find the mean of the sample variances. We should get the same number. Average. Yeah. So our population variance is equal to the average of all the sample variances. I think that was part B in the problem. Yeah, compare the population variance to the mean of the sample variances. Yeah, the population variance is equal to the mean. And also, so this is something that I went over in the Excel video. Hopefully all of you watched. And do the sample variances target the value of the population variance? Well, yes, because they're equal. The sample variances, once you have all of them, you have, and once you have every possible sample variance and you average them out, you get the population variance. So yes, that is true. Okay, what else? Any other questions? Okay, so if there's no other questions, let me just finish up the call by talking about the exam. So that is week 12. All right, so just like the last exam, you have a week to do it. You only have one attempt. So when you open the exam, you have to finish it in one sitting. So basically all the information here for exam number 2, I just copy and pasted the info from the first exam. I think it was week 6. The only thing that's changing is the due date and the sections covered. So it's exactly the same format as your first test. I'll tell you what my feedback has been from my students over the past many years. The feedback I've gotten is that the second exam has tended to be more challenging than the first exam. Now, that said, since you have an entire week to do this test, to prepare for and do the test, I recommend spending a significant amount of time, and I mean hours, studying for the test. Now, studying does not just mean doing practice problems. That's part of it. So just like for the first test on MyMathLab, you have, let's see, right here, you have 3 practice exams, 1 for each chapter. You don't have to do every problem on every exam, but the more you do, the better. We have a Zoom call, even though next week is the exam and there's no new material, we still have our Zoom calls next week. Monday at 2:30, if you're in that section. Tuesday at 7 a.m. if you're in that section. Anyone is more than welcome to attend both of those calls. I mean, both classes have access to the other classes' Zoom calls. So on my, as always, you have one page for Zoom meetings for section 08, one meeting for section 10. So you have the link. Everyone has the link to my Monday meeting and my Tuesday meeting. So for those meetings next week, they are to review for the exam. So just like today, it's you ask questions, I give you answers. If everyone shows up to the call with not many questions to ask, it's not going to be a very long or productive call. So please join the call, our next call, Monday or Tuesday, whichever one you choose to join, or both. Please have questions ready, and they could be questions from the homework, questions from the quizzes, or questions from the practice tests. Now, one thing you might want to do, since you have access to all the old quizzes you've taken, you might want to go into the 2 quizzes that we've had. There was the quiz for chapter 4, and there was the quiz for chapter 5 and part of chapter 6. So for each of you individually, when you log on to your MyMathLab account, don't go to the assignments, go to your gradebook. And when you're in your gradebook, next to every assignment, you could click on review. So if you click review next to quiz 4 or review next to quiz 5, you could open up the quiz. It will show you what questions you got right, what questions you got wrong. It will show you the correct answer. So if there's a question you got wrong, it will show you the correct answer. And it will also show you the answer you put in. So in terms of studying for the test, I recommend going back to those 2 quizzes and redoing any problems you got wrong, because if you got a question wrong on the quiz and you haven't gone back and figured out why you got it wrong, well, you might see that exact same question on the test. Just like the first test for this exam, there's no surprises. Every single question on our upcoming test will be a version of a problem you've already done on a test or on a homework or a quiz. Everything is similar to one or more questions that you've already done. So if there's questions you got wrong in the past, particularly on the quiz, go back and redo those problems. Another thing I would recommend doing, if you did this for the first exam, great. If you didn't, then you might want to do it for this exam. So not only do you have my lecture videos where I go through my PowerPoint notes, you also have my PowerPoint notes. I mean, hopefully you've been using them already, but it might not be a bad idea to open up the PowerPoint notes for each section and sort of pull out like the important stuff, something, anything that's really important, definitions, formulas. If it was me, I wouldn't write them down by hand manually. If it was me, I would take it, what I recommend you doing is taking advantage of the work that I've already done for you. Okay, so when you're going through my notes, anything like here, definition, probability density curve. So if that's something you want to add to like your list of notes for the test, you could just select it and copy and paste it into a Word document. So, instead of spending, a ton of time handwriting all of the stuff that's already in my notes, that's an option. There's nothing wrong with that. If you want another option to save time, also, if you want, you can, copy individual slides into a new PowerPoint file and just pick the ones that you want to use during the test, or you could copy and paste into a Word document, either way. But you definitely want to, the test is open notes. So you definitely want to spend some time putting together some notes. Whether it's, like I said, whether it's notes you handwrite, a how-to guide on Excel, or putting together Excel templates like I walked you through earlier in the week. You want to, part of studying is doing problems. That's like the main part of studying is doing practice problems. But also preparing for, studying for an exam involves preparing your materials, especially, like I said, when you have an open notes exam. The more time you spend putting together your notes, the easier it will be to reference those things you need as you need them. Okay, so that's what I wanted to say about the upcoming test. Also, and I talked about this the other day, the extra credit assignment. So, extra credit assignment, it's due no later than midnight on Wednesday, December 23rd. Please don't ask for extensions. Please don't email me on the 23rd saying I'll get it to you tomorrow. The day after that Wednesday is Christmas Eve, and I plan on not doing any work. I plan on spending that time with my kids. So I will be grading the projects as they come in. Hopefully, no one's sending me the project on the 23rd, but you can if you want. I'm going to finish grading these projects at midnight on the 23rd. I will not grade any projects that come in late. But that's it. I mean, no big deal. You have more than a month to do it, and the project shouldn't take you too long because it's all stuff you've already done earlier in the semester. It's worth half a letter grade, 5 points, 5 total overall points to your overall semester grade. So if you finish the semester with an 86 or an 85 and you do the extra credit project, you get an A for the semester. Or if you finish the semester with a 76 or a 77 and you do the project, you get a B. So this is a very significant, this is a very large chunk of extra credit points. I usually make this project worth 2 points, but I bumped it up to 5 this semester because of the whole added stress involved with the online learning. So this is a big extra credit opportunity. So what you're going to turn into me. So you submit this, obviously not on Moodle because I've never mentioned the word Moodle. I don't use it. You submit this to me via email. It says it right here. To submit the assignment, you will email me 2 files, the written analysis and the project template. So right here, project template to fill out and turn in. This is the project you're turning into me. Okay. So let's talk about the projects. I am giving you these two Excel files, this per capita GDP data, that's an Excel file that you download. You'll just click on that and you'll, if you click on that, it will automatically download that Excel file. Same thing for life expectancy data. So these two data files you download. The first one lists every country in the world and their per capita GDP. So the per capita GDP, that's basically if you took all the wealth a country has and you divided it equally between every person living in the country, that's how much each person would get. Some countries have more, some countries have less. I just want to scroll to the bottom. Okay, so 184 countries. You see the US is right here at 48,112 per person. Okay, 184 countries. There are not 184 countries in the world. There are more than 184. But the website I used to get this data only listed the data for 184 of them. The other file, life expectancy data. Let me pull that over from my other screen. It lists, again, for each country in the world, the average life expectancy. So Afghanistan, you have two values. You have their per capita GDP, and you have the life expectancy of people living in that country. Then Albania, per capita GDP, Albania, life expectancy. Algeria. Okay, now look at the list on the right. You see a problem here. Well, first let me go down to the bottom, and then we'll come back up and talk about the problem and what you have to do with it. On the left, the per capita GDP data file has only 184 countries. The one on the right, the life expectancy, has 193. Now, there are going to be some countries on one list that are not on the other, and vice versa. So what you have to do first is organize the data. So remember, my definition of statistics: the collection, organization, analysis, interpretation, and presentation of data. This project hits on the last four. I've collected the data. You have to organize it, analyze it, interpret from it, and then present it back. So you see on the right, you see the country of Andorra with a life expectancy of 82. Well, there's no Andorra on the other list. So it's gone. You can't use it. You can only use countries that appear on both lists. So the first thing you have to do is just go through both lists, and anytime there's a country that is on one of them and not on the other, just go in, delete. So Afghanistan, Albania, Algeria, so on and so forth. So just you go through each list and make sure you've deleted any countries that appear on one list that don't appear on the other. And it's easy to keep track because the rows are numbered. So you just make sure, like, let me scroll down a bit. Number 100 on this list is Macau, but number 100 on this list is Malawi. So if you've done it this correctly, and you've deleted every country that's only on one list, if one list has Macau as number 100, the other list should have Macau as number 100. All right, so that's step one in the project. Once you do that, just copy that data over to my template. So everyone's project should look the same. What you turn into me. Okay, so once you've deleted everything, you would just cut and paste. You don't have to type anything manually. Just cut and paste the name of each country in column A. Copy those GDP numbers in column B. Copy those life expectancy problems in column C. And then you'll do a little bit of work over here. So, and all this stuff is quick because you're using Excel. The mean, the median, the standard deviation of each one, the correlation coefficient. That's probably the most important number here, because the scope of the project is, examining, based on this data, is there a correlation between how much wealth a country has and how long the people living in that country live? And that's what we did back in chapter 2. And so you'll make a frequency distribution for each one, a frequency distribution for life expectancy and one for per capita GDP, also a relative frequency distribution. This should be pretty easy because I've done most of the work for you. I've set up the classes. You don't have to worry about the class width or anything like that. I've done all of the, I've set up the frequency distribution for you. All you have to do is count. All you need to do is count the frequencies. Once you have that, you'll generate a histogram. Again, that's just, select and insert. Basically, like, once you fill this out, you highlight, insert the graph. And once you have numbers in there, you'll have that bar graph. So that shouldn't take, there shouldn't be any one step in this problem that is difficult. I've done a lot to set it up for you. I think the most time-consuming part of the project is just going to be deleting those countries. Just sorting through the list, just, scroll down little by little and delete anything that doesn't occur twice. That's it. Once that's done, the rest of the project should be pretty darn straightforward because it's all, pretty much set up on this template. So you're going to insert 3 graphs. A histogram for life expectancy, a histogram for GDP, and under here, a scatter plot with the regression equation. And again, those graphs, it's just highlight, insert, and click on the graph icon. So making those graphs just takes a couple of clicks. And I've posted very detailed directions, everything that I've just said, it's laid out step by step. I give my directions. Part 1, organize the data. You must delete that country from the list if it's not on both. Copy them into the template. And then the other part of the project is the written analysis. So I give you some questions to answer. So this is basically just by answering these questions, you're writing the beginning of the analysis. It's not a long analysis. I think I said just 1 page or 2 pages. I can't remember. So the paper must be a minimum of 1 page. That does not include the top where you have my name and your name and the date and the class and the title, all that, like that stuff at the top of a paper, that doesn't count. That 1 page of text begins when you start your opening paragraph. It's going to be, you're not going to have to worry about filling a page. 1 page, single spaced, 12-point font. You're not going to worry about filling a page because it's going to be very difficult to answer all of these questions without going over 1 page. I definitely think this is a project that you could do in 1 sitting. You might want to just do it in 2 sittings. You might want to do all the Excel stuff and then maybe write the paper later. I mean, I think you could do the whole Excel portion of this project in less than an hour. I mean, it should not take too long. But it should also be, my goal is that it's not terribly difficult, but it is very informative. Okay, so that's all I want to say for the project. It's posted on the ePortfolio. Somewhere, yeah. So you have extra credit assignment, you have the directions, you have the template to fill in, and you have the 2 data files. All right, that's basically all I wanted to say today. Does anyone have any other questions before we end the call?
So I just wanted to ask, I know someone before asked about redoing exercises on MyMathLab, but like if I use 2 attempts out of 3 for the quizzes, and then I want to use the 1 left for like practice for the exam, will that affect my score?
Yes. Yeah, I mean, if you open the quiz late, it will be graded. But it doesn't matter because only the high, if you take, let's say if you've taken the quiz twice and then you open it a 3rd time past the due date, it will be graded, but it won't affect your grade if it's, because only the highest grade counts out of the 3.
Oh, so I could use it just to practice.
Yeah.
Oh.
You know what? And thank you for bringing this up. When this call is over, actually not immediately because I have another Zoom call to hop onto real quick, but I will repost the quizzes. So it will say quiz 4 practice or quiz 4 doesn't count. So I'll post another copy of quiz 4 and quiz 5 that will have unlimited attempts and won't be counting towards your grade. So you won't have to worry about that.
Oh, okay. Yeah, because I had like this 1 attempt left on each quiz, but then last time I was going to do that, but I wasn't sure. So I wanted to ask this time to like just make sure. But okay, that helps. Thank you.
All right, thank you. Okay, anything else? Going once, going twice. Okay, everyone, have a great weekend.
you.
And I hope to see you all on Monday or Tuesday or both.
Thank you.
Thank you.
You're
Have a
welcome.
nice weekend.
Thank you. Have a nice one.